Have you ever used water to test to see if a surface is ready for cooking? This surface is hot but not quite ready. The water that strikes it boils away fast. This surface, on the other hand, is much higher in temperature and ready for cooking. The droplets that strike this surface bead up and ride across it. This curious phenomenon is known as the Leidenfrost Effect. To start learning about the Leidenfrost Effect, let's heat this steel sphere for a short period of time and then place it in some water. In this case, the water quickly cools the sphere back to room temperature. Now let's heat the sphere until it glows orange hot and try the experiment again. Well, that's curious. In this case, the steel sphere is hotter, but it hasn't yet caused the water to boil. If you look closely, you'll see a layer of gas that surrounds the steel sphere. That's insulating the sphere from the water. The steel sphere does cool slowly until finally. Let's view the hot sphere underwater, close up and in slow motion, to get a better idea of what's going on with the Leidenfrost effect. The Leidenfrost effect comes into play when a liquid contacts a surface much hotter than its boiling point, just like what's going on here with this hot sphere and the water. When this happens, the water hits the hot surface and boils really fast, so fast that it forms a layer of gas around the hot sphere. It looks like a bubble in the video that you're looking at. The vapor barrier protects the liquid from the hot surface and makes it so the liquid doesn't even touch the hot surface. The sphere does cool slowly until finally. Let's watch some super slow motion video of this process. At this point, the steel sphere is hot enough that the protective vapor barrier has formed around the steel sphere. This is the Leidenfrost effect. The steel sphere continues to cool. At some point, it's no longer hot enough to support the vapor barrier. Water rushes in, collapsing the vapor bubble. This allows the water to make contact with the sphere, which is still pretty hot. This contact rapidly cools the sphere and also causes a lot of water to boil. The entire process of vapor bubble collapse takes much less than a second to happen. In this super slow motion video, a water droplet is placed on a surface a little bit higher than its boiling point. In this case, the water droplet quickly boils away. Let's compare this to a water droplet being placed on a surface that is much higher than its boiling point. In this case, the Leidenfrost effect kicks in. A vapor barrier is formed in between the droplet and the hot surface. The water is protected from the hot surface by the vapor barrier. The droplet rides across the hot surface much like an air hockey puck rides across an air hockey table. So the next time you flick water on your griddle to see if it's hot enough to cook pancakes, remember, it's the Leidenfrost effect that helps to make these beautiful beads of water.